Okay, welcome to surface area, pyramids and cones. So today we're going to look at the surface area of these two items. We've already looked at the surface area of prisms and cylinders. So now we're going to check out pyramids and cones. So let's start with the pyramids. Now, truthfully, the drawing for me of the pyramids is going to be pretty ugly. So a lot of what I'm going to do, I will end up doing nets of the pyramids because it will be a whole lot more understandable. So let's say we're going to start with a square pyramid with a base length of 6 centimeters. So I'm going to go ahead and I'm going to draw my square pyramid, 6 centimeters here, and it's square, so I'm just going to put 6 over there so that we know that we are dealing with a square. And we have a slant height of 18.4 centimeters on this. So I'm going to go ahead and make my triangles. Frankly, they're not going to be consistent. However, we do know that because it's a square that all of these sides are going to be 6, and all of these slant heights are going to be, what did I say, 18.4 centimeters. Okay, so when we are talking about surface area, as a reminder, it is everything that is on the outside of our shape. So basically, when I come up with this number, it should mean that if I were cutting out my shape and putting it and gluing it together, this is the amount of material I would need to actually build it. It is the outside surfaces. Each surface has a specific area, and we're going to add that together. So we're going to start with our base, which is the square, 6 times 6. So our base is 36 centimeters squared units. Okay, now we've got triangles, and we've got 4 of them, and they are all going to be the same. So remembering that the area of a triangle is equal to 1/2 the base times the height. In this case, I'm going to have 1/2. My base is 6, and my height is 18.4. And let's just remind ourselves that because of the commutative property of multiplication, it doesn't matter which order I do this in. So I'm going to go ahead and take 1/2 of my 18.4. That will give me 6 times 9.2. Okay, so I'm going to go ahead and do that math. 9.2 times 6, we get 12. 6 times 9 is 54, 55, and 1 decimal place. Now, I have 4 triangles that are exactly like this. So I'm going to go ahead and just multiply this number times 4. 4 times 5 is 20. 4 times 5, 20, and 22, with 1 decimal place. And I'm going to bring this number up here and add it to my base, which is going to give me 256.8. We're in centimeters, and my unit is squared. So if that looked easy to you, that's good, because really surface area is not complicated. It's just a matter of understanding what all of your numbers are. So so that is a square pyramid. Now, let's think about if we had a triangular pyramid. Let me see if I'm looking at a triangular pyramid. Okay, so let's say I've got a triangular pyramid, and I can't draw it once again, so I'm going to go ahead and I will just net what I have. Okay, so I have a base pyramid that is 8 feet across here, and it is apparently 8 feet on all sides, so I have an equilateral triangular base, which means that the base of my other 3 triangles will be the same. So, and then I'm going to net the other triangles. Basically, it just looks like a big old triangle cut up into pieces. And my lateral height appears to be, let's see, my lateral, my slant height is 6.9. So my slant height here is 6.9. And actually it appears that the height of my base pyramid is also 6.9. Okay, so it appears that I've got 4 triangles that are exactly the same. This is kind of how I want you to look at these things, so that you are saying, okay, yes, I have a base and 3 attached triangles, but in this case, they all have a base of 8. They all have the height of 6.9. So this is going to be 4 times 1/2 base times height. Okay? Now, if I look at it this way, I can say, well, 4 times 1/2 is 4 halves, or 2. So this is actually going to be 2 times my base times my height. Just makes your equation a little bit more easy to look at. So, so what this is going to do now, my base, so I've got 2 times my base, which is 8, and my height, which is 6.9. Always make sure that you keep your decimals lower than your multiplication sign. So this becomes 16 times 6.9, and so I'm going to go ahead and do some math. 6.9 times 16, 54, 36 and 5 is 41, and then 9 and 6, 4, 10 and 11 with 1 decimal place. So I am looking at 110.4. I'm in feet, so this is feet squared. Now, your book is going to talk a lot about lateral area and surface area. Now, just so that we are clear, the lateral area is simply the surface area minus the base. Okay, so really all you're going to do is reduce it by 1 triangle. Lateral area comes into play in certain places. They are going to ask you to do lateral area. If we look at our top pyramid here, this pyramid will, you would just have, for a lateral area, it would just be this, okay, the 220.8, because you're not going to add that base in. So when they talk about lateral area, please understand that's all they are talking about. So that is really all on our triangles. So now let's look at our cone. Our cones are really pretty strange because their nets are all sorts of different. So when you have a cone, you typically have a net that is going to look somewhat like this, and then you have a circle, because this area's got to kind of go around the circle, and then this has got to make a point. So so in drawing that, it actually is a little bit easier to draw than the pyramids, because you do just have that circle base and then that 1 point. So it's not all that difficult, and sometimes it's harder actually to understand the net on these, but we'll look at numbers for both of them. So let's say we've got a radius on our cone of 3.5 yards. And I'll put it here also, 3.5 yards. Okay, and a slant height of 10 yards. So this here is my slant height. And then you're going to see your slant height right here. Okay, so in the case of the cone, we need the area of a circle, which is pi times the radius squared. And then the area of, I don't even know what to call that shape. I don't know, it's not a pie, it's just a funky cone shape. We will call it that, the funky cone shape. You are going to use, so we'll call it, or should we call it weird cone shape? CS. I have no acronym for it. So just cone shape, okay, we are going to use pi times the radius times the lateral area. Okay, so we're going to multiply pi times our radius and our lateral area. So the whole thing, surface area, is equal to pi r squared plus pi rl. And all we're going to do is drop numbers in there, okay? So let's drop some numbers into this. So here we've got 3.14 times 3.5. Do we want to leave it like that? We will. We'll leave it as 7/2 squared. Although we're in decimals here. You know, we could probably use 22/7 in this case. Let's go ahead and instead of using this, let's go ahead and use the 22/7. See how that works for us. And then we've got pi, which is our 22/7 again, our radius, which we know is the 7/2, and our lateral height, our slant height, which is 10. Okay. So yeah, this makes way more sense to me. So 22/7 times, now when we square this, it's 49/4 plus 22/7 times the, let's multiply this, so that's 70/2. Okay, we'll go ahead and multiply these together. First, let's reduce them. Oh my gosh, that'll be so fun. We'll reduce before we do anything. Make that 2. 2 goes in here, 11. So this becomes 77/2 plus, and then we'll reduce this to 1, this 11. This is a 1, and this is a 10. So 77/2 plus 10 times 11, which is 110. Oh, I'm having fun with this. I hope you're enjoying using fractions, because fractions definitely are our friends. Now I'm going to go ahead and convert this. I've got to add this to my 110. So 2 goes into 7 3 times with 1 left over. Goes into 17 8 times with 1 left over. So 38 1/2 plus 110 is equal to 148 1/2, and it is yards squared. And yeah, that really works pretty well. I think that that was very easy. So you might disagree, but you know what? You're probably still using decimals and still doing a lot of multiplication, and I'm done. So so yeah, yay me. So if you're working with a fraction, you may want to consider going to the 22/7 and work it that way. So so with the cone, the important thing is to remember this pi r squared I'll write it again, plus the pi r and the slant height. Okay, and once again with this right here, this is going to be lateral area. Okay, and you can barely see that. And then this part here, this is the base. So just understand which is which. So I do want to just tell you very quickly before we leave this and move on about spheres. Okay, so with our spheres, we know that the area of a circle is pi times the radius squared. So I'm like way off there. And when we do volume, well, when we do area, we'll forget volume. I'm sorry, I don't even know why I brought that up. When we do the area of a sphere, what we are going to do is we're going to say, well, we're breaking it up into 4 parts, and we've got to cube our unit. Now that's volume. So we're breaking it up into 4 parts where it's very confusing as to why we get the 4/3 without looking at volume. I just don't want to confuse everything. 4/3 times pi r squared. So, no, that's 4 cubed. I'm sorry. I am so totally confusing you right now because I have confused myself. So the area is 4. You know, I need some help. Let's get the pirate. Let's get the pirate in here. Arg! Arg, matey. She's all over the place with this. Let's try this again. You're not even going to have problems on it, but you should know it. Arg! Okay. Thank you, Mr. Pirate. Okay, let's leave you there for comic relief. Okay, for pi r squared is surface area. It's almost like you're taking that circle and just making it into, 4 different directions, and I don't know, 4 pi r squared. That's what it comes down to. So, so just for future reference if you need it. And that's it, because really I think I've done enough here. Arg. I hope she's sure about that. Okay, so anyway, enjoy.